Magnetism. Introduction. Look around your home and try to find a magnet. A magnet is a metal object that sticks to other metals. You might have some magnets among your toys. These are probably magnets on your refrigerator. But did you know that there may be hundreds of magnets in your home? You cannot see most of them, but there is inside your television, telephone, and stereo. They are inside motors that power your blender and hair dryer. Computers are full of magnets, and all the electricity that runs these things comes from magnetism. Magnetism and magnets. Magnetism is an invisible force. A force is anything that pushes, pulls, or moves an object. Magnetism is a special force that only pulls on some metals, such as iron. A magnet will not push or pull plastic or tin. Magnetism flows in one direction through a magnet. No matters what shape the magnet is. It flows is one end and out the other. The ends of a magnet are called magnetic poles. Every magnet has a north and a south pole. The force flows at the north pole and back in the south pole. You can use two magnets to feel magnetism flowing. The north pole of one magnet will stick to the south pole of the other. Now try to push the two north poles together. It feels almost like trying to connect two hoses that are both spraying water. The magnetic force pushes the north poles apart. Because the magnetic forces and flowing against each other, two north poles will always repel each other, so will two south poles. The Earth's iron core is magnetic. The whole planet acts like a giant magnet. If you dangle a magnet by a string, one pole will point north and the other will point south. This is exactly how a compass works. This gives the north and south poles of a magnet their names. Magnetic field. The magnetic force flows out the north pole of the magnet. Then it loops around outside the magnet and flows back in the south pole. Magnetism flows through space in lines of force. The invisible shape formed by the lines of force around the magnet is called the magnetic field. Any iron or other magnets inside a magnetic field will be pulled toward the magnet. Stronger magnets have more lines of force and larger magnetic fields. To see a magnetic field, place a magnet on a piece of paper, sprinkle iron fillings around the magnet. The fillings will gather along the lines of force in the shape of the magnetic field. How are magnets made? The first magnets were made of a natural rock called limestone. People used pieces of limestone in compasses, but they did not know how they worked. Every material is made of extremely tiny pieces called atoms. Most atoms spin. This spinning creates a tiny force. In most things, like rocks or plastic, the atoms spin every which way. The tiny forces never add up, but when something becomes becomes magnetized, the atoms spin in the same direction. All the tiny forces add up to create a magnetic force. Eventually, people learned how to line up the atoms in some needles to create new magnets. Something such as iron become magnetized more easily than other. A piece of ordinary iron is placed inside a stronger magnetic field. The magnetic force makes the iron atoms line up and spin in the same direction to make a new magnet. The more atoms that spin the same direction, the stronger the magnet becomes. Sometimes, if you drop a magnet, some of the atoms get knocked out of line and the magnet gets weaker. Magnetism and electricity. Magnetism and electricity are very closely related. Magnets can make electricity, and electricity creates magnetic fields. This is because both magnetism and electricity affect the way atoms spin. All the electricity use comes from machines called generators. Generators make electricity by spinning magnets around coils of wire. The magnetism creates an electric current in the wire. The difficult part is getting the magnets spinning. Power plants use running water, white, or steam for burning fuel to turn the magnets. Electric can create special magnets called electromagnets. A wire is out, wrapped around a regular piece of iron. Then an electric current from a battery or outlet flows through the wire. The electric current makes a magnetic field. This magnetizes the iron, but the iron only stays magnetized as long as the electricity is on. Using magnetism. The earliest use of magnetism was the compass, a small freely moving magnetic needle pointed to Earth's magnetic North Pole. This helped guide travelers and explorers. Modern travelers still use compasses. Electricity comes from spinning magnets inside generators, and electric motors work like generators in reverse. They use electric current to spin magnets. The magnets are attached to fans, cutting blades, or wheels. This is how fans, blenders, and remote control cars work. Magnets can also encode information or store it in a special card. Hotel key cards and credit cards use strips of tiny magnets. The magnets are the size of grains of powder. There can be millions of magnets, no one key card on or credit card. Each tiny magnet points in its own direction. The different positions of the magnets create a card. Credit card and hotel door reader sense the tiny magnetic field and read the card. Putting a credit card or key card near a powerful magnet can mess up or erase the card. Some high-speed trains run on electromagnets. The trains have powerful electromagnets. On the bottom, the track also has powerful electromagnets. The two electromagnets face each other so that they repel each other. The magnetic force is so strong that it lifts the train off the track. The rail floats above the track. It actually flies as it travels. This makes a fast, smooth ride. Special machine called MRIs can look inside a person's body. The person lies inside a tube cut right down the center of a very powerful magnet. The lines of force flow through the person's body. The magnetism is so strong that it causes the atoms in the body so strong that it causes the atoms in the body to spin in the same direction. Special sensitive instruments can tell how fast the atoms spin. Computers figure out what kind of atoms they are based on how they spin. This gives doctors an idea of what is going on inside a person's body. Doctors can find atoms that are not supposed to be there. They can see cancer and other diseases. MRIs give doctor a look inside the body without having to cut the body open. Conclusion: while magnets may seem simple, there is no end to their uses. Every time you watch a tape, turn on the air conditioner, or even turn on a light, you are using magnets. Someday you may ride on a high-speed train or use an MRI. Playing with magnets can be lots of fun. The magnetism you play with is the same force that has made modern life possible.